Okay, what I would like to do now is do one more problem that isn't so perfect, that the signs come out a little bit differently. And number 15 from section 4.4 does that. Let me just do a quick run through on this problem. Do it with me, and you'll get the logic of it. So we'll go through the sequence again. Let's take the derivative of f of x, find the critical numbers. F prime of x is equal to 12x to the third minus 12x squared. Therefore, that is equal to, it looks like 12 is common and x squared is common. That gives me x minus 1. So when I set this equal to 0, I get 12x squared equals 0, which means x equals 0, and x minus 1 equals 0, which is x equals 1. So in our number line that we were talking about, I mentioned sometimes you have numbers or you don't have an integer in between, and that's the situation right here. Looks like we've got 3 regions to consider, and the one to the left, we can get a -1. And the one in the middle, the easiest number to work with is going to be 0.5 or 1/2, 0.5 or 1/2. We'll see how multiplication goes, see which one is easier to use. And then to the right, they'll use 2, the integer, the smallest integer we can use. So we're concerned about these situations right here. And what does the function end up being? So I've got f prime of x is equal to 12x squared times x minus 1. Notice I'm leaving it in factored form to write it out. Sometimes it's easier to do it in factored form. Sometimes it's easier to leave it in the earlier, the entire function if you want to do it that way. But both times here, I'm going to go ahead and plug it into the factored form, and we'll see where that gets us. All right, so we're going to plug in the values that concern. -1 at the slope of at -1 is equal to 12 -1 squared, -1 minus 1. So I've got 12 times +1 times -2. So I end up with -24. So it's a negative value, -24 over here. All right, then let's look at f prime at 0.5. Or I might use a half. Well, we can use 0.5. But we've got 12.5 squared, positive 0.5, right? And then we've got 0.5 minus 1, which gives us 12 times 0.25 times -0.5, which you can see positive, positive, negative. This is going to end up being a negative answer. See, like showing your work, that would be sufficient. You can show me the answer is negative. That's what you want to find out. This is positive here. This is negative here. And the last one, f prime of 2, is equal to 12, 2 squared times 2 minus 1. You can see they're all positive. You got positive, positive, positive. So you could just answer it and say this answer is positive. So we end up with, in this case, what happened here? Oh, this was negative. Oh, I said that was positive. This one's negative, right? So we've got a negative value here, a negative value here, and a positive value here. Negative value meaning that the slope, it means it's coming down like this. The negative value, this one, the slope is negative, so it's coming down like this. And the positive in the last one means it's going up like this. So we don't have them meeting up at the top. The only place they're meeting is down at the bottom. So we've got a local min at x equals 1, and there is no local max in the situation that we've got in the diagram. And so we could plug it in and find out what the coordinates are, which would give us 3 times 1 minus 4 times 1. It is 3 minus 4, which is -1. So the coordinates are 1 minus 1. So we have a local min at local min, excuse me, let me erase that for a second and just say we've got a local min equal to -1 at x equals 1. We determined that. That was using the first derivative test to determine our local extrema. All right. Hope you're well. And if you hit there's probably, I think there are 19 problems that I've given from section 4.2. There's only 2 from 4.3. And I didn't find a lot of good problems to do from section 4.4. So I'm going to give you a worksheet on Wednesday. We'll do that together and be able to work it out together in that fashion, and we'll go from there, okay? So I'll see where we come up with that. I'll give you some problems to do from this section. I'll probably, you know what, I'll probably do it in there today. I'll give you the problems to work, and you can bring them tomorrow on the worksheets on Wednesday. It's going to be work the problems out. It'll be office hours. You can come if you want to. If you got questions, let me know during class time. And then Thursday we'll do an in-class problem set, and it'll act as a assessment, so to speak, a graded deal, where we'll do some problems and work them out. I'll let you do them yourselves first, and then I'll work it through and make sure we're together on it, and have them due by the end of class period. Okay, so that's the plan of attack. Hope to talk to you before too long, and hope to see you tomorrow. Well, I'll see you tomorrow if you've got questions. Other than that, I'll see you Thursday. Or hear you anyway. Talk to you soon.